every time you join, just make sure that you have some IDE open so that you can just practice some of the sessions, because some of the things, I think they didn't give that much practice in the book, especially with lists. So we're gonna just attempt some of that, and some of the things that I think you should be able to use as a programmer, such as using the help. Okay, so I'm gonna try and go at a good pace with this. I'm assuming that most of you have read it again. We are on the chapter list and loops in the book Python for Biologists. And again, for those who will be joining us and watching this videos online, these are not the usual type of, you know, just having lectures online where you can watch them and you get the full on scope of what you can do with it. And in fact, no lecture is like that. You will always find that some of the main things are covered, and some of it you will just have to use the help menu for. But this group, we work individually at home through the chapters in the book called Python for Biologists. The links I will put at the bottom of these videos. And then we attempt the exercises at the end of the book, also on our own. The answers are in the book. Then we come together a week later in order to just see where everybody got stuck, or to discuss some additional things that maybe weren't in the book that I felt was necessary to address or to teach. So if this looks like, this is basically a study group, so if it looks like it's meant to be a lecture and you're not getting that out of it, then yeah, there are plenty of other people or content creators that do create lectures for that. So list and loop. So a little bit of a background. Obviously, we are all aspiring bioinformaticians and maybe data scientists or software developers. And as a data scientist or a bioinformaticist or bioinformatician, I don't know yet. This is an ongoing discussion about what it really is. You will definitely be dealing with big data. Some of you have already, in the form of VCFs and all of that. And these types of data that we are using are normally too big for an Excel file. Some of them are fine to store in it, but as soon as you start to have to work with it, your system starts to freeze. And so we need something that we can use. We need a scripting language or some form of system that we can use that allows us to parse or to read all of the information in a file very quickly, to be able to manipulate it and do things with that file, which is usually the case with biology. Again, you have lots of data that you want to extract from there or remove from there, and you want to be able to do that quickly without your entire screen or computer freezing. And so this is why we use something like a scripting language like Python. But especially for biologists, we're really getting into the nitty-gritty now of the things that you will always be using if you're dealing with big data. And one of it is looping. So looping is when you basically, in a kind of a repetitive manner, you loop through some of the whatever data you want to loop over, and then you normally do something to that data. And this can be, again, you do something to every part of that data, or you would have certain conditions that are being set, and if something complies with that condition, you do a certain thing to that. Now, at the moment, in this group, we haven't done conditionals yet, so this will be just doing something repetitive to data. But once we start getting to the next chapter, then you really start to see the power of what we can do with something like lists combined with looping, or just looping in general. So looping allows us to automate a process, and this takes care of, obviously, speed. And at the same time, it takes care of monotony for those of us who get bored easily. And also, it helps us to prevent making errors if your code is written correctly, of course. So something like this would be an example of something that you would do there's something that you do manually, and you can actually write a script so that the computer does exactly what a human would do with a smaller file. the computer would do with a bigger file. So let's say, for example, you have two files where you have genes in the SNPs in the TP53 gene, right? You would then, for example, you want to find SNPs that are common to both of these participants. So you would, for example, take SNP1 and you would say, okay, is SNP1 the first SNP RS54 in file 1 also present in file 2, and you would scan all the lines in this file, and then you would go to the SNP RS111, you would scan all the SNPs in here and try and see if you find matches. So this is the type of thing that you would normally do as a biologist. Now, again, we are not going to be able to do it here because we're not doing conditionals yet, because this requires you to set up some form of rules and constraints. But this is the type of thing that you do often, and this requires looping. It's a repetitive, look at this, compare to all of that, take the next one, compare to all of that, until you've done it to all of your lines. Right, so again, this sort of thing is nice to do when it's just 4 lines each, but it does become problematic when you're working with something like a VCF file where you have hundreds of thousands and millions of lines. You obviously want to have a computer take care of that for you. So one of the data structures that we're going to be looking at today that actually allows us to do this very well is lists. And this is one of the data structures that I actually also use often together with dictionaries. But lists for sure I use a lot, and I'm sure that you guys are going to use it a lot as well. Lists are a type of a data structure or data type that allows you to store multiple pieces of information in there. And what's nice is that you can store different types of information. So it could be, and they can be mixed. So it can be integers, floats, booleans, anything, and all kinds of other complicated data that we haven't really looked at. And then it comes with its own methods. If you can remember from last time, we talked about methods. Methods are almost like these little tools that you get that are specific to that data type. And lists also has methods that allows us to tease out the information in the list so that we can access things within the list that are important to us, or that we want to use later on. It comes with some built-in methods that can be used. How we recognize lists is normally, again, that it has a variable name. So in this case, if you take, for example, this file, this first file, and I take all of the SNPs in here, I can put all of these SNPs in a list. And I could call it intuitively what we learned in chapter 1, participant 1 SNPs is equal to, and you will notice that it has these square brackets, and you would have all your items in your list in there separated by a comma. A list, all of these individual items within the lists are called elements in computer science or programming jargon. So if you have an element, they're talking about a list and the individual items within there. An empty list looks like this, just nothing in there, just square brackets.